So dear students, we start and we solve for example 1. In the previous lesson we discussed about the capacitance of a parallel plate capacitor, that C is equal to epsilon naught A over D. So this formula is for the capacitance. We need area of the plate, separation between the plates. Okay, now in this lecture we solve example 1. So first let me introduce the given information, the given data. So they calculate the capacitance of a parallel plate capacitor whose plates are 20 by 20 by 3 centimeter. So area is given 20 centimeter multiplied by 2.0 centimeter. That gives us 20 over 100 meter multiplied by 2.0 divided by 100. That gives us 20 by 20 multiplied by 3.0. 20 multiplied by 3, that gives us 60 into 10 to the power minus 4 meter square. So the area of the plate is given. Okay, we need capacitance of the, so other informations are the potential V is 12 volt and potential V is 12 volt, and what is electric field we also find. So in the part A we find calculate the capacitance of parallel. Okay, now in this part A we find capacitance. In part B we have to find the charge, what is the charge on the capacitor. In the part C we have to find electric field intensity between the capacitor plates, and in part D we have to find the area area of the plates, so area A of the plates. Okay, so in order to find the first part capacitance, we use C is equal to epsilon naught A over D, epsilon naught A over D. So we have the values. Epsilon naught is the constant that has value 8.85 into 10 to the power minus 12, and area is given 6 into 10 to the power 60 into 10 to the power minus 4 divided by D. Separation is between the plates, that is given 1 millimeter, 1 into 10 to the power minus 3 meter. So D is 1.0 into 10 to the power minus 3 meter. Okay, so we solve and get capacitance, that is equal to 53 into 10 to the power minus 12 farad. That gives us 53 picofarad. Okay, for the part B we need the capacitor charge Q. So the simple formula for in the Q is equal to CV. So it C is the capacitance, that 53 into 10 to the power minus 12. In the previous part we already found the C. We put this value of C 53 picofarad multiplied by the potential is 12 volt. Now we multiply, we get the charge, that is 6.4 into 10 to the power minus 10 coulomb. Okay, for the part C we need electric field intensity. For the part C we need electric field, so we use potential gradient equation, that relationship between E and V, that is E is equal to V over D. So the potential is 12 volt and the separation is 1 into 10 to the power minus 3 meter. That gives us 12 into 10 power 1.2 10 power minus 4 volt per meter. Okay, so for the last part D, so we have to estimate the area for a capacitor if capacitance is 1.0 farad and the separation does not change, means separation is 1 millimeter. So in this case the separation is 1.0 into 10 to the power minus 3 meter. 1 millimeter is 1 10 power minus 3 meter. Okay, no other changings, only the capacitance is 1 farad. So we use same equation, C is equal to epsilon naught A over D, and now we rearrange for area A. So area A is equal to C multiplied D over epsilon naught. So C is 1.0 farad, D separation is 1.0 into 10 to the power minus 3 meter, and divided by the epsilon naught 8.85 into 10 to the power minus 12. So that will give us the capacitance, new capacitance, that is 8 10 power 8 meters. So very big capacitance, very big area. So it means if we want to store the 1 farad, so it requires 10 power 8 meters square. That is the very big area. Okay, thank you. In this equation you just need to, in this example you just need to have the, you have to remember the formulas. Capacitance formula, C is equal to epsilon naught A over D, for Q is equal to CV, V is equal to V over D, and C is equal to the same equation. Okay, thank you.